Pro tip, do not upgrade your OS before a trip, which I never, ever do. All right, so this is why we're getting not Tahoe. Okay, so I'm Ben Curtis. I'm a co-founder of Honeybadger. You can check us out at honeybadger.io. If you don't know about us, we do exception monitoring and uptime monitoring. If you have a web app in production and you actually care about your customers being happy, then you should use Honeybadger, because that's what we do for you. So today, I'm going to take a little different style than I usually do. I usually have like 60 slides. Today, I have like 6 slides. Hang on, let me set my timer so I don't go over. So hopefully it'll be okay. But what I'm going to do today is invite you to our ops meeting. So every month at Honeybadger, we have an ops meeting, and I'm like the ops guy at Honeybadger. And we just coordinate on like what's changed in the past month, what's going to change in the next month, and also we often have a show and tell. So that's what I'm inviting you today to join us with. We're going to have a show and tell about some of our infrastructure at Honeybadger. And I mean, you're not running Honeybadger, so why would you care? Make it a little more generic. I'm going to talk about why or how you can actually deploy your web app to AWS. I'm going to go over every detail, and maybe I'll bore you to tears. Maybe this will spark some interest, hopefully more the latter than the former. But I'm going to talk about infrastructure as code, that's what IAC is, and Terraform. So who's familiar with infrastructure as code already? Okay, perfect. I'll just skip that then. No, I'm just kidding. Infrastructure as code is when you have some sort of configuration in a text file somewhere. You can commit that to Git, and then that somehow manifests itself as infrastructure, like you get deployed, right? Terraform is one of the tools that you can use for infrastructure as code. Basically, it has this syntax that you follow, and as long as you have the right incantations, then next thing you know, you've got firewalls and networks and web servers and so on. There are other tools, but I like Terraform, so we're going to talk about Terraform. And then our deploy target today is AWS ECS, and of course, 50 gazillion other services. Because the way AWS works is it's all Lego blocks. Like you get a bunch of things, and you put them all together, and if you do it correctly, you get stuff works. And if you don't, well, then you don't. So we'll talk about that. ECS is AWS's Elastic Container Service. So assuming you have a web app that can be rendered as a Docker container, then you're in business. We're going to put that container on the web today. And if we have time, then we will get to how to do that automatically with GitHub Actions. And that's how we do it at Honeybadger. Like we do a git push, and then magic happens, and then we have stuff deployed. Right? That's how it works. And just for giggles, this is so until we get to the point where the AI is good enough to actually launch stuff from your laptop to the web, then we still have a job. Okay, so let's go. All right, so I'm going to walk through a complete Terraform config, and I might run out of time, but we'll get as far as we can. All right, so first, this is HashiCorp's syntax, HCL, and it looks kind of like JSON, kind of not. It's fine. We're going to start by setting up our Terraform config. We're going to store our state in S3. So what Terraform does is it says, hey, I want to make some things happen in AWS, and I'm going to keep track of all those things that did happen in a state file. You can, by default, keep that state file locally, but it doesn't help if you have a teammate, right? So we got to put that state file somewhere where other people can share it, and we're going to put it in S3. You can put it in Dynamo. You can put it in all kinds of places. I like S3. All right, we're going to use the AWS provider. So you can do a lot of stuff with Terraform. You can deploy DigitalOcean droplets, Lino things, all kinds of stuff, right? But you have to have a provider that tells Terraform how to do the things. And we're doing AWS today, so we're going to do that. All right, we're going to deploy to the EU Central 1 region. But I just wanted to show this. This is a variable definition. So you can override these variable definitions with environment variables. So you could put in secrets here if you wanted to. Or maybe if you have a stack in the US and a stack in the EU, you might have slightly different configurations in those two places. So that's how you can do it with variables. And you can just see how you use a variable right there, var.region. Okay. Let's start by creating a VPC. So VPC in AWS is basically your private little cloud. You're partitioned off from everybody else. In fact, you can partition off from other things that your own business is doing, right? It helps with security. We're going to have a CIDR prefix of 10.2, and we'll use that variable below. We're creating these /16 networks, right? So we have a bunch of IP addresses. And in our case, our US is actually 10.1, and our EU is 10.2, and then that allows us to do like peering, and there's no conflicts of IPs, okay? All right, so we're creating our basic VPC called HB. We're giving it we got a tag there, so we know it's a production. That var.environment environment actually equals production right now. All right, so first thing you got to do is you got to create a gateway, because All you get is a network. Now, how do you actually get to the internet? Well, through a gateway. Okay, cool. Now you actually need to specify a route that says, hey, send all traffic to 000, which is everywhere, through that gateway, all right? So if you want to talk to anything, it's out there, go through that gateway. Now we create multiple subnets. So in Amazon's world, a subnet, is a well-known network thing, right? You break up your traffic into smaller chunks. But what we do is we actually map each of our subnets to a different availability zone. And these availability zones are different data centers in the same region or in the same city. So if you're in Ashburn, if you're in Frankfurt or wherever, presumably there are different buildings that host different availability zones, right? So we got A, B, and C, and so we're creating 3 different subnets. Why do we do this? So we can deploy our tasks to multiple of those data centers at the same time, and then now there's high availability, right? If one of those data centers gets hit by a truck and blows up, we still got 2 more, right? So that's what we're doing here. We're setting up a .1, a .2, and .3 subnet. And you'll notice that, like this here, this VPC, we're referencing that resource that we created a few minutes ago. We're now referencing that inside of our subnet, and you will see this resource show up a lot later. So as you build resources, you can then reference them as just like variables, and they slot in rather than having to hard code a bunch of stuff. I forgot to mention, if you have any questions, feel free to yell at me as we go, because sometimes I skip things. So please just stop me, and I'll try to remember not to skip things. Okay, so we got a network in place. Now we need a firewall, and that's what a security group is in AWS parlance. We've got to say we're going to let some traffic in or keep some traffic out. This is just a default security group. Like, you probably shouldn't have anything in the default security group. You want to specify things like per web or per database or whatever. But it's good to have a default because sometimes you just need a trash can to put stuff. All right, so here's our first real security group. This is for the web. So we're going to allow web traffic in. We're going to allow 443, and we're going to probably allow some 80 down below. One interesting thing is, like, for some reason, AWS likes to break things up by IPv4 and IPv6. So you have some duplication if you actually want to support both v4 and v6. All right, so we got our 80s in there just in case someone from 1996 is browsing our website. And then we have a security group that, again, web, so we're deploying web apps, so that's what this is. And 5000 you might recognize is the port that Unicorn likes to use back in the day. So that's why we're opening up port 5000. So this allows anything in our network to talk to the web apps that are going to be attached to the security group on port 5000. Otherwise, nothing would be able to talk to them. So you got to have a rule for everything you want to do. And our last ingress rule, this is the tricky one. This is one you might forget. Allow any traffic from myself. So if you have 2 instances that are in the same security group, but you don't have this rule, they still can't talk to each other. Brilliant. All right, so we allow all traffic from ourselves. And you cannot forget the egress rule, which allows you to actually send traffic out, right? If you want that web server to actually be able to respond to a request, you got to let that traffic back out of the thing. So we let traffic go back out to 000. You can actually use this to great effect to prevent exfiltration attempts, right? If you have some specific rules about where things go, you may not want all your traffic going everywhere, but in this case we do. All right. So we got our firewall. Now we need some actual domain names and some load balancers to actually start routing traffic into our thing. So var.domain, in this case, honeybadger.io. It's not a private zone, it's a public thing. And we've got some more variables. We've got an API host and an app host. This, again, just showing like the variance. So in the US, this is like API and app. In EU, it's slightly different. So we can reuse the same Terraform for multiple stacks. We're going to create an ACM certificate. So this is our SSL certificate that Amazon will generate for you. And it's effectively a wildcard. I'm not showing every detail here, but basically every domain that we want to serve, app.honeybadger.io, api.admin. Whatever, can all be in the same certificate so that they can all be used by the same load balancer. We got a Route 53 record, so Route 53 is the service that provides your DNS resolution. So we're actually going to validate our domain with AWS to let them know, yes, we actually have this domain so that you actually can create a certificate for us. I don't know why you have to do that, but you do. There you go. That's what that is, and there's the validation, and now we're getting into the actual load balancer itself. So there's a variety of different types of load balancers. We're going to talk about just an application load balancer today, which allows you to do things like route web traffic to different endpoints. Kind of fun. And as promised, here are the subnets showing up again. So we're actually going to deploy this particular load balancer that AWS is running to all of our subnets, right? So traffic gets routed through and gets to each subnet that our app is running in. I'm not going to show you this, but we actually created an S3 bucket elsewhere in our config that is used for the logs that the load balancer is actually going to be saving for you. All right. And this is kind of the weirdness of AWS as well. Like, it's not cool just to have a load balancer. You got to have a load balancer that actually listens to a port. So here we go. Set up port 443 to listen on my load balancer to start send the traffic. And there's our certificate that we just created a few minutes ago. And we get to pick like what kind of level of TLS we're going to support. This default action I'll come back to in a little bit. But basically, we're going to say, hey, we're going to send whatever traffic doesn't get rerouted for whatever other reason. It's going to go to this place, this what's called a target group. And I'll come back to that. And in Terraform, you can do fun things like ignore changes that AWS might make to your infrastructure. I'll come back to this in a second, but in this case, the default action might get changed. In fact, will get changed for this load balancer. And if we run Terraform again, then it'll be like, oh, wait, something changed. You should change it back. But actually, we want that change to just be ignored because, like, we know, yeah, cool, Terraform, that's fine. So you can ignore changes if you want. And finally, here's our route 53 record that will send traffic from app.honeybadger.io to the place we need to go. All right. Actually, this is just a DNS record. And that A says, hey, pointed at that load balancer that we had. OK. Any questions so far? We're not anywhere near having the web app deployed yet, but we're already like 20% done. OK. Next step. This is a tangent. So blue-green deployment is pretty cool. If you're not familiar with it, it allows you to have a set of good stuff that's running, like your current live traffic, and now I want to deploy a replacement thing, and I want to test that the replacement deployment is actually working before I switch all my traffic over to it. So that's what blue-green deployment is. It's kind of awkward to set up in AWS. This whole bit of code that I'm about to show you is just does that one thing. So basically, we use code deploy, yet another AWS service. We have to give it a role because everything in AWS needs permissions. You can't do anything without any permissions in AWS. So we create a role for our deployer thing to actually be able to deploy stuff. And that's what all that is. And we say, okay, there is a code deploy app called app. And it's kind of weird. But then we give it some rules. Like, what do you do if the deployment fails? Do you roll back? Do you just leave it as is? That sort of thing. So that's what that configuration is about. And this is kind of fun. We actually have some custom log metrics that we track, like how many boot errors we get from Puma, or how many 500 responses a load balancer actually returns. And if these alarms get triggered during a deployment, then it'll actually automatically roll back to the good deployment, right? So if for whatever reason we wrote some code that Puma can't even boot, it'll detect that automatically and just abort the deployment. Pretty awesome, actually. We give it 15 minutes to settle. So that gives us 15 minutes to, if we notice something's wrong manually, we can go in and like, reboot, abort. And we tell it which service we're going to point to. And that's ECS service is what's actually going to be hosting our app, and that's we'll get to in just a second. And then again, this target groups thing. You'll see there's 2 target groups defined here, and that's that we got a blue and we got a green. And this is that ignore thing I was telling you about a minute ago. We actually need to ignore this change because the code deploy is going to be changing that default target based on which set gets deployed. Deploy A will be green and blue, and then the next deploy will be blue and then green, and it just alternates back and forth. It's very hard to find configuration on the internet that does this. I can't tell you how many hours it took me to figure out how to do all this. So if you want this config, just let me know. I'll send it to you. Save you a bunch of time. All right, so target group is how we tell AWS, hey, we got this traffic that's amorphous, and we want it to go to this particular place, right? So traffic's coming in on HTTP. We want to go to port 5000 to this particular location, blah, blah, blah. And the page, like, here's the health check. How do you know that target group is actually up and working properly? There's the second one, blah, blah, blah. And now we have to connect the listener to that target group via a listener rule. So we're saying, hey, if in this case, we're using a host header condition. So if the host matches app.honeybadger.io, then send it over to this target group that's going to be running our app. You can have other conditions like paths, and we do this in other places where these paths go to that target group, and those paths go to that target group. But we're not doing that here. We're just checking the host. It's because we send app traffic to a different target group than we do API traffic, for example. They're different apps. And again, we're going to ignore those changes there. All right, next step. let's actually start deploying some stuff now. So we've got an ECS cluster, so you can't just run a task. You have to have a box for the task to run in. That's called an ECS cluster. And you have to have a repository in ECR, which is Amazon's Elastic Container Repository. That's where you shove your Docker image so that it can then be pulled down when your things get deployed. And of course, we have to have a log root. If you want to have a log anywhere, you've got to have a log root for it to log to. And back to the permissions, all right? So if you want your thing to actually be able to write logs, well, you got to give it permission to write logs. And if you want to pull an ECR image, you got to give it permission to pull the ECR image, and so on and so forth. So there are two permission things you got to worry about with ECS. One is the thing that's spinning up your task, and then when the task is actually running itself. So first is what permissions you're going to give Amazon when it's doing its thing, and then what permissions you're going to give your app to do its thing. All right, so in this case, we're talking about the first, like how do we deploy? Well, we got to be able to actually write some log events, so we're going to do that. We're going to actually allow the deployer to pull secrets from our secret store. Get to that in a second. We're going to allow it to do some ECR things, that is actually pull the image. And what else are we going to allow it to do? That's it. Okay, so the next role for the app itself, we're going to let the app do some stuff. We're going to let the app also grab SSM parameters because it loads things in one of our initializers. We're going to allow it to have actually interaction. You can actually interact with your Docker container as it's running in the Amazon environment. Pretty cool. That's what these permissions allow. And so on and so forth. Other permissions it's got to do. I mean, anything you think of. Access a bucket, write to a dynamo table, whatever. You've got to be super specific. Or you could just do star and then let someone own you. But prefer specificity. All right. So now we're getting kind of into the nitty-gritty of how we actually get our task, like our actual Docker container out there. So we're going to create a task definition. This is the configuration that the Docker container is going to be running from. So we can specify how many CPUs we want to allocate, how much RAM we want to give. And we're also going to deploy to Fargate. So there's actually two ways to deploy an ECS. One, where you don't care about servers. It's just Fargate. You just, hey, Docker container, go run it. Great. And another one where you do care about servers, you have to run your own instances, and that's, I've never used it. Don't worry about it. It's not cool. All right. What are we going to do? We're going to specify container definitions. So each ECS task can actually run more than one container. It can run however many containers you want. Usually it's one, but you could do more. So we have this array of containers, and we just happen to call it app, and it's coming from our ECR repository. So that thing where we've pushed our Docker container, it's now going to pull it down, and it's pulling it down with the latest tag. You'll see later that'll change. And by default, we'll just run whatever the Docker container is configured to run in a Docker file, but you can override it. So we deploy our app both as a web thing, and we also have our Sidekick config in there, of course. So we run web tasks, and we run Sidekick tasks. And the Sidekick tasks have this in their task definition to override the command. And then this is where we're connecting the logo bricks, right? We've got the port 5000 that was in our target group. Now we've got the port 5000 that we're listening to. We're going to expose that in Docker parlance and tell it which logs to write to. This is the interesting bit about how you configure your environment. So these are all environment variables that will show up in the environment for the task itself. And you can pull in things from other parts of your infrastructure. So I'll probably skip it, but if you want to see it real quick, here's how we deploy a Redis cluster. Okay, cool. That was exciting. So we've got that Redis cluster deployed, so we can actually reference that in our Redis URL. And then again, we've pulled in a bucket that we've created elsewhere. Super secret stuff that you wouldn't necessarily want to have in your configuration, you can put over in SSM parameter store. You could also put in like the two other services that AWS offers for this kind of thing, but we like parameter store, so we use that. So these also show up as environment variables. It's just they're secret environment variables. Okay, and we got a mount point because we have a shared file system where we do stuff. All right, so that's our definition, and now it's like, let's actually run this definition, and that's what an ECS service is about. A service runs a task or multiple tasks. So we're calling it web. We're putting it in our cluster. We're giving it a task definition that I just showed you, and how many do we want to run? And how long do we want to let it run before it has a health check that's valid, and so on. All right, and so this is where we're going to put it in those three different subnets. Of course, if we only run one, well, we're just in one. But if we run three, now it's going to distribute across each of these availability zones for us. It's pretty slick, actually. And which security group do we want to be in? And do we want to have public IP and blah, blah, blah. And this part is like the key to get that blue-green deployment working. If you forget this part, none of that other stuff works. Ask me how I know. All right, and connecting it to the load balancer and ignoring some changes. So the task definition will change, and I'll show you that in just a second, but it changes for every deployment. And then when we have auto-scaling, which is described right here, with auto-scaling, we'll change that desired count. So we don't want to be running Terraform and telling it to override what our auto-scaling is also telling us. That's why we ignore it there. So we can say how many we want to run max, how many we don't ever want to go below, and that's what this configuration is about. And then this configuration here is what's our policy? How do we decide when to auto-scale? The absolute simplest one is just go on CPU. But you can, this is what this is here. But you can do things like how many requests are coming in per second, or what my queue latency is, whatever metric you can measure in AWS, which is like a gazillion of them. You could make that your basis for doing auto-scaling. Fun fact is that Amazon will tend to favor availability over efficiency. Kind of works out for them because they make more money off of you, but it's also good for you because your stuff is so low. So if you look at an auto-scaling chart in AWS, you'll see it goes way up, hangs out, hangs out, hangs out. It's like, yeah, then it starts to come down here. You know, probably like 30 minutes after it could have gone down. Yeah, that's just the way Amazon does it. All right, so we briefly skipped by that Redis cluster there. So let's talk about how we actually get all this stuff running. So now we actually, if we had a Docker image in our repository, all of that stuff that we just did now has it deployed. It's running, it's taking web traffic, it's all good. So how do we get stuff into Docker, right? Well, you can do a manual push. I mean, everybody knows how to do that, right? Or you can let GitHub do it for you. And so this is the config in Terraform that actually sets up the connection between GitHub Actions, and AWS. And in a way that you don't have to give GitHub a long-lived token that has like all kinds of crazy permissions. Like you do not want to do that. So OpenID is the way that they've come up with to do that. And basically is the handshake between GitHub and AWS says, hey, you know, AWS, we trust you to take this stuff. And AWS says, hey, GitHub, we trust you to send some stuff to us. And that's what this is all about. And again, of course, there's permissions involved. And so that's why we've got to assume the role, allows them to be a federated, blah, 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 right? And one thing that's pretty cool about this is that you can actually specify, okay, which repos actually have authorization to be pushing stuff into AWS. Super, super handy. And we get this role, blah, 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 has permissions to do all kinds of things like push to our repository or trigger code deploy, right? You see all these things start to come together. And we also have assets that we push to S3, so we got to add some permissions for that bucket because, you know, who wants to host the assets themselves? And attach all those policies, et cetera, et cetera. And finally, one fun thing about Terraform as well as outputs. So you can, after you're done with your Terraform run, you can have it spit out some of the things that it created. And so in this case, we're going to spit out that off role that we're using because we've got to put that over into GitHub to say, what role do you want to try to assume when you run the actions? Okay. Good so far? Any questions? All right. So let's take a look at, this is just our asset. I'm only showing this one because it's actually a middle part of our workflow. So we run tests, all right, and that's what you'd expect, you know, bundle rake test, whatever. This particular workflow is triggered once that test workflow is successful, right? Right here, right? If that, blah, blah, blah. So if the test failed, none of this happens. But if it works, then what we do is we take our role that we got just now from our Terraform config, and we use that for authentication, and we do some stuff. We set up a Ruby, we run assets, blah, 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 and we push them to S3, okay? Not terribly exciting, but I want to show you that because that is the thing before the thing that's really interesting, and that's where we create our ECR release. So I just didn't want this to go unexplained. This workflow is dependent on that workflow that I just showed you, so it's kind of like this daisy chain of workflows, right? If the assets fail, like we don't want to deploy the rest of the things because like bad things have happened. Let's figure that out. All right, so we have a workflow at Honeybadger where no code changes go live if they don't have a PR and a review, right? So we have a PR, there's a review. Once it's approved, that gets merged to master, right? So we don't have pushes to master, we have merges to master, and that's why we only look at master for these workflows. If that CDN assets thing based on master is actually completed, we start to do the rest of this stuff. This is a fun one. This one kind of got us for a while. Usually, a GitHub workflow will just go based off the head, SHA, right? Well, what happens if you got a merge to master, and the thing started kicking off, and now you're on the third workflow here, and now there was another push to master in the meantime. If you're still on the head SHA, now you're building something that you didn't actually go through all the stuff necessarily, right? So we pass along this workflow run. Give me the SHA that was done that worst, that last one. So I know I'm having the same SHA that's going to assets, going to tests, and blah, blah, blah. Ask me how I know about that one. Okay, so we're going to push our Docker image. Again, with our head SHA there. So you'll see a lot of examples where they build, like here, do a build, and then immediately do a push. Fine, that works. Until you want to reuse this image in multiple places, like, for example, deploying to US and EU, right? So what we do instead is we save that image to the asset stuff that GitHub hosts for you, and we upload that, okay? And we separate out our push into a different task so that we can have a matrix, US East and EU Central. And that matrix then will download that image that we just saved and push it. So we're not building multiple times, right? Save us at least 2 minutes of GitHub actions every time we deploy, right? Because I'm that way, right? I'm persnickety. All right, so we got our AWS credentials. You'll notice that we do not have an access key or a secret key in here. It's just the role, because we have that OIDC connection already made, so we don't have to have those secrets being exposed like that. And then we deploy each region. Okay, so we log into ECR, we tag it, and we push it. Cool, that all makes sense. And then ask me how I know about this one. You should delete your artifacts after you're done using them. GitHub will happily charge you for all those artifacts that you left behind for all your runs. Okay, and then we need to update the web task, and this is where the magic happens. So we say, again with our 2 regions, so what we did is we pushed that Docker container to 2 different regions. You could always pull from one region, but I figured it's just nice to have it in 2 places. It makes the pull a little faster. Again, we're going to configure our credentials. We're going to download the task definition that we created with the Terraform, where it has our environment variables, it has our secrets and stuff like that. We're going to download that task definition. We're going to replace that latest tag with this SHA tag, so that each task so every time we deploy, we have a new task definition that has a new SHA tag. So if we have to do a really bad rollback where we missed that 15-minute window, now we can just revert that task definition to the one before it. It's got that previous SHA, that known good SHA, as opposed to all of them you're always using latest. Like, you don't want to be writing latest on every deploy, right? Does that make sense? So that's what this does. It describes that task definition, pulls that JSON down, swaps out that thing, and pushes it back up to Amazon to create a new task definition. That's what this does. And then we check out our code, because in this case, we're using that, again, that blue-green code deploy thing, which requires this stupid little YAML file to say, yes, I really do want that container to really get traffic from that port. Thank you, Amazon. All right. So that's what all this is about. The only reason we have to check out is to have that one file. And it's frustrating. But there it is. So there you go. That is a full Terraform configuration for taking code from your repository all the way to production. And that is what I have. Thank you. I have 2 minutes, I think, if there are any questions or suggestions. Ryan, run it. Run what?
Don't actually run it. Don't run it.
Any other questions? Yes. Oh, go ahead.
Hold on, Pat.
Yes, I know. Hold it to my chin. Okay, so I saw web servers, app servers, API servers, all kinds of stuff that can be ephemeral and horizontally scalable.
Mm-hmm.
Do you persist data, and if so, where?
What kind of data would I want to persist?
User data, stuff coming in. I mean, do you guys use a database?
Okay. Yeah, I skipped the whole database thing. I cheated on that. So let me go back to that. Step 3. Database URL. So we use Crunchy Data. So they have our Postgres database. It's actually VPC peering, which I can talk to you about later if you're curious about, to keep it secure, not on the public internet. But basically, I got that. I handed that. I've put that value into SSM parameter store, so I can just pull it down here. So if you want to use RDS because you're silly like that, because I don't love RDS, then you could have your Terraform config build your RDS, and then you could get that database credential stuff and put into it, just like I didn't show you with the Redis, the Elasticache thing. Like,
Okay, so I did have a follow-up question on that.
Okay.
So you use a hosted Postgres service. So they handle all the maintenance, so things like, say, resizing it or major version upgrades whenever that happens. What's your experience when that happens? Is there do connections disconnect or like their application connections to the database? Does that connect? Is there disconnect? Is there like 10, 30 seconds of downtime for application for those major things? What's the experience for like specifically resizing database servers and major version upgrades whenever that happens?
yeah, Crunchy is very similar to Heroku in that case, where basically they have a follower that is ready for the next version, and you do a flip. They do a flip, and it takes 2 or 3 seconds. Sometimes you have to bounce some connections, but we also use PG Bouncer, and that just handles that kind of transition very smoothly. So we might see a blip of 2 or 3 transactions are like, hey, the data went away, and then it's back to normal.
Cool, thanks.
I got time for one more, I think, because now I'm out of time. Go ahead.
Hello, Ben. Hello. Hello.
Hey, Mike.
That looks like thousands of lines of very bespoke, fragile YAML that you developed over years.
It's about 10,000 lines of Terraform.
Doesn't seem very Rails-like. What do you know? My point is, do you know of any tools that are trying to standardize this and conventionize it so that instead of, I moved from Java to Rails because Spring had thousands of lines of XML and Rails just made it disappear. Are there tools that are starting to hide this kind of stuff and standardize this kind of stuff?
Yeah.
I'm thinking of like Heroku and Hatchbox being two, right? I mean, Heroku makes pant loads of money because they basically hide all this, right?
Yep.
Check out Miren, miren.dev. That's Evan Phoenix's kind of not quite stealth thing to be a Heroku-like maybe for that. So I don't know if it answers your question, but check out Miren.dev.
Cool.
You showed us your deploy process for rollbacks. Is it also handled via GitHub Actions? And is there kind of a hot rollback process that does not require you to merge to your main branch?
Yeah, no, so if we have to abort a deployment manually, if we want to trigger a rollback, we do that in 2 ways. We could do it usually in the AWS console. We also have a Slack bot that we can do that. We can send a command and it'll do that. And if we have to do a rollback to a previous version, that we do manually, because that should never happen. And I think it's happened once in the past maybe 5 years, so yeah. Yeah.
All right, round of applause.